Welcome to qnawire.
So now we're going to work on problem 83 from chapter 5. In this problem, we're asked about the fulminate ion, particularly in comparing it to the cyanate ion, since they have the same three atoms, oxygen, carbon, and nitrogen, but they have very different properties. So cyanate is stable, but fulminate will form explosive compounds. So we want to draw the Lewis structure and all possible resonance structures for the fulminate ion and use that to explain why it's so much less stable. So the fulminate anion is CNO minus, and so we want to draw our Lewis structure with this form. So carbon, then nitrogen, then oxygen. So if we count electrons, we have 6 from oxygen, 5 from nitrogen, 4 from carbon, and 1 from the negative charge. That's a total of 16 electrons. So in our Lewis structure, we've already used up 4 with the bond, so we have 12 electrons left to assign. So if we assign like this as lone pairs, that takes up 12 electrons, but then we have nitrogen deficient of 4 electrons. So we're going to share 2 pairs of electrons from each atom with the center atom. And so now we've used up 16 electrons, and every atom has their octet. So this here would be negatively charged. So we can also draw the resonance structures before we work on the formal charges. So the next resonance structure, we could have, instead of 2 double bonds, we could have a triple bond and a single bond. And that could be between either between the carbon or the oxygen. So this here is our second resonance structure. And we're going to have a third one with the triple bond between the nitrogen and the oxygen. So if we calculate Lewis structures for each of these compounds, then we'll see that carbon here on the left will be 4 minus 6, so negative 2. Nitrogen will be 5 minus 4, so positive 1, and oxygen will be 0. For the center resonance structure, we now have a 4 minus 5 for the carbon, negative 1. 5 minus 4 plus 1 for nitrogen, and then 6 minus 7, negative 1 for oxygen. Now for carbon in the resonance structure on the right, we have 4 minus 7, so negative 3. 5 minus 4 plus 1 for nitrogen, and 6 minus 5 plus 1 for oxygen. So all of our resonance structures have a formal charge adding up to negative 1, which is good. But we see here that all of our structures have high formal charges. Only one 0 formal charge is oxygen. So we can open up a new page here, and we can go ahead and write down the factors that contribute to instability. Because this question really is asking us, why is this fulminate anion so unstable as compared to cyanate? So first of all, we have high formal charges. In no way are the formal charges, they're minimized as much as possible for these structures. For instance, probably the most stable resonance structure would be the left side, where it's minimized, or perhaps the middle, but we have still a lot of formal charge. So high formal charges. Next, we have negative formal charge on the carbon. Carbon typically has a formal charge of 0 in many compounds, but typically it's more favorable to be positively charged than negatively charged. And all three of our resonance structures have a negative formal charge on the carbon. So that is an unstable factor. And finally, the third factor which contributes to this is the fact that in all of these here, we have a positive formal charge on the nitrogen. Nitrogen will be more electronegative than carbon, so it should be negatively charged, if at all. And so in each of the resonance structures here, we have a positive 1 charge on the nitrogen. This alone wouldn't be a huge factor contributing to instability, but coupled with all of the other factors, it creates a very unstable anion.